Welcome to this video. So in this video, we are going to look at a question on double integrals. All right, so the question states, sketch the region R bounded by the curves x is equals to y squared and x is equals to y cubed. Okay, and then B, they're saying evaluate the double integral over this region R. And then C, interchange the order of integration and evaluate this integral again. Okay, so the curves that we've been given here, x is equals to y squared. And then the other one is x is equals to y to the power 3. So the first thing that we need to do here is make y the subject of a formula. Okay, so I can say y squared is equals to x. And then I take the square of both sides. I'm going to have y is equals to the root of x. Okay, and then here, I'll say y to the power 3 is equals to x. So this will just give me y is equals to the cube root of what? Of x. So remember, we want to sketch this R that is being bounded by this and this. Okay, so in short, it's bounded by this curve and this curve. Okay, so I've made y the subject so that I can easily sketch this graph. Okay, so what I'm going to do is that I'm going to draw a table of values here. Okay, let me make it a little bit bigger. So this will be my table of values for these two curves. Okay, so I'll say let this y is equals to root of x be y1, and then let this one be y2. So I'll say this is my x, and then what will be my y1, what will be my y2. Okay, so I'll divide, I'll pick about 4 points. I think those are enough. Okay, so I'll pick 0, 0.5, 1, and maybe 4. Okay, so if I have these as my x values, what will be happening to the y values? Okay, so if my x is 0, it means y1 will also be 0 because the root of 0 is just 0. So I'll put 0 there. Okay, and then even the cube root of 0 is also 0. So this will be 0. Okay, and then if x, okay, is 0.5, it means that my y will be equals to, my y1 will be equals to the root of 0.5. Okay, so if you punch this on your calculator, it's approximately 0.7. Okay, what about my y2? Okay, so it will be the cube root of 0.5. So the cube root of 0.5 on my calculator, it's approximately 0.8. So here I write 0.8. Okay, so what if my x is 1? Okay, if my x is 1, then the root here will just be 1 as well. The cube root here will also be 1. Okay, and then if my x is 4, then my y1 will just be the square root of what? 4, which will be 2. Then my y2 will be equals to the cube root of 4. So this one you just punch on your calculator. So when I do that, I'm getting approximately 1.6. Okay, so here I'm going to write 2, and then here I'm going to write 1.6. So I'm going to use now these points to sketch these two curves. Okay, so let's erase this part, and then we sketch the region R. Okay, so I'm going to say, let this one be my y-axis, and then let this one here be my x-axis. Okay, so this can be 0. I have 1/2 there, and then I have 1, and then somewhere, okay, after 2, 3, 4, I have after 2, 3, I have 4. Okay, and then here I'll do the same. I have 1/2 somewhere, and then I have 1, and then I have 2 somewhere there. Okay, so let the 2 be somewhere there. So let's increase this one a bit. Okay, so this is what we have. So now let's try to plot these points. So I'm going to plot the y is equals to 1 in green. Okay, so it will be 0, 0, this one, and then 0.5, 0.7. So 0.5 is just above this half, which is 0.5, right? So somewhere there. So I'm going to put my 0.7 there. Okay, so this is half 0.7, and then I have 1, comma 1. So my 1 is coming like that. So it means this is my 1, comma 1. Okay, and then I also have 4, comma 2. So 4, comma 2 will be somewhere there. Be somewhere there. Okay, so this is my curve. Okay, for y is equals to the root of x. Okay, or we can say y squared is equals to what? To x. So this is the curve. It's not a straight line. Okay, so make sure you draw your points accurately. Okay, so this is the curve that we have for y is equals to the root of x, or y squared is equals to x. Okay, and then for the other curve, which is this one now, I'll use blue. Okay, so for y2, I'm going to use blue. So I have 0, 0 there. And then I have 0.5, 0.8. So 0.5, 0.8. So if this was 0.7, then 0.8 should be somewhere above there. Okay, so that's my 0.8. And then my 1, 1 to still be this same point. And then my 4, 1.6. So if this is 2, 1.6 should be below it, somewhere there. Okay, and then I'm going to connect this point with this curve in blue, like that. Okay, so this curve in blue is actually y is equals to the cube root of x, or we can say it's a part of y to the power 3 is equals to what? To x. So now which one is our region that we are considering here? Okay, so the region that we are considering is basically this region that is between the green and the blue at curve. So we're considering this region here. Okay, so this will be our region here. So the question was that we have to evaluate this double integral over this region in two ways. Okay, we evaluate it in one way, and then we change the order of integration. We also evaluate it. Okay, so from this region, we can come up with two types of regions. Okay, we can come up with type 1 and also a type 2. So I'll write the limits for those types here on top. Okay, so if we consider this region as a type 1, okay, if it is a type 1, then our region will simply be equals to, okay, x comma y, such that, okay, so if it's type 1, it means we're getting constant along the x, so it will be from 0 to 1, so it will be 0 all the way to 1 for the x, and then we're getting continuous functions along the y. So continuous functions, we are moving in this direction like that. So this one, the green one, it will be the curve that will be below, and then the blue one will be a curve that will be above. So the green one, okay, since we are writing it as continuous functions of y, I'm going to say this one, the green one here. Okay, the green one there will just be simply y is equals to root of x. So I'm coming from the root of x all the way to this one in blue. So this one in blue, it's y is equals to what? To the cube root of x. So it will be the cube root of what? X, like that. Okay, so let me write it properly. Okay, so we said type 1 equals to r is equals to x comma y, such that along the x we get continuous functions, along the y, okay, I mean along the way x we get the constants, and then along the y we get continuous functions. Okay, so it will be like this. Okay, so this is what we have as our type 1 region. Okay, if we take this region as a type 1, what if we take it as a type 2? Okay, so type 2, it means my region will be in this form. So it will still be x comma y, but now I'll be getting constants along the y here. So along the y, the constant is from 0 all the way up to 1. So it will be 0 all the way up to 1. And then along the x, I'm getting continuous function. So now I'm not moving like this, I'm moving like this. Okay, so I'm moving from this blue curve to the green one. So the blue curve is what? It's simply x is equals to y to the power 3. So it will be y to the power 3 all the way to the green one, which is this one here, which is y is equals to x squared. So I'll put y squared like that. So we have those two regions there. So now let's try to evaluate this integral in this region for the type 1 and also in this region for the what? For the type 2. We see if we are going to get the same answers. Okay, so I can erase this region of ours so that we evaluate. Okay, so let's start with the type 1. Okay, so the type 1, it will be our integral will be equals to, so the limits here are from x is equals to 0 to 1, and then y will be equals to root of x all the way to cube root of what? X. And then I have 2x plus y squared dy dx. So these ones are the limit for y. So the y follows immediately. And then the one that is outside, we also have the dx outside there. Okay, so this is going to be equals to, okay, so let's integrate this with respect to y. I'll get 2xy plus y to the power 3 over what? 3. And then I'm putting these limits there. And then dx. Okay, so from there, what do I get? I just have to substitute. Okay, but before I substitute, notice that the root of x is just the same as x to the power half. And then the cube root of x is just the same as x to the power what? To the power 1 over 3. Okay, so when I'll be substituting these limits, I won't be using the cube root of x or the square root of x. I'll be using this x to the power something. Okay, so it will be the integral from 0 to 1. And then here, wherever there is y, I'll be substituting with the limits. So it will be 2x, okay? Then I put the cube root of x, but I write it in this form. So it will be x to the power 1 over 3, and then plus x to the power 1 over 3. I'm replacing this y now to the power 3 over 3. Okay, and then minus. Now we substitute the square root, which is x to the power half. So it will be 2x, and then I have x power half minus x power half to the power 3 over 3, and then d what? Dx. Okay, so that's what we have there. So let's continue. So I'll erase some of these things. Okay, so it means now we have the integral from 0 to 1. And then here we can simplify this. So this is 2x multiplied by x to the power 3. So this x has a power 1, and then it's being multiplied by x to the power 1 over 3. So we can add those powers. Okay, what we get there will just be 2x to the power 4 over 3. Okay, and then plus here, I will multiply this 3 with the 1 over 3. So that will just be x over 3. And then here it will be 2x. This x has a power 1. So 1 plus half. Okay, I'm going to get minus 2x to the power 3 over 2. And then here, okay, I'll just multiply the 1 over 2 with the 3. So I get minus x to the power 3 over 2 divided by 3. Okay, and then dx. So this is what I have. Okay, so from here we can add some of the common things. So 2x to the power 4 over 3. And then this one remains the way it is, x3. But these ones here, they have x to the power 3 over 2, x to the power 3 over 2. So we can combine them. So when we combine them, I get minus 7 over 3, x to the power 3 over 2 dx. Okay, and then from there now, we can integrate with respect to x. So when we integrate with respect to x, okay, what we get is 2x, okay, to the power. So if I add 1 to this, I get 7 over 3. Then I divide by the same power, plus x squared, okay, and then I divide by the same power, this 2, which is multiplying this 3 down. And then here to be minus 7 over 3. Here, when I integrate this, I'll add 1 to the 3 over 2. Okay, so I get x to the power 5 over 2 divided by the same by the same power, which is 5 over what? Over 2. And then I can put the limits 1 and 0. Okay, so here, let's substitute. Wherever there's x, we put 1. Okay, so this one just becomes 2 over 7 over 3 plus this one becomes 1 over 6. This one becomes minus 7 over 3. Okay, and then this one here is just 1 over 5 over 2. Okay, and then if I substitute 0, it means everywhere will get 0. So minus 0 like that. Okay, so this tells us that our integral will be in this form. Okay, so 2 divided by 7 over 3 is the same as 2 multiplied by 3 divided by 7. So I get 6 over 7 plus 1 over 6. And then here, I have minus 7 over 3 multiplied by 1 over 5 over 2. So 3 multiplied by this, I get minus 7 over 3 multiplied by this is 15 over 2. So this part is the same as minus 7 multiplied by 2, which will give me a minus 14, and then divided by this same 15. Okay, so this is what I have. So I can find my lowest common multiple for this. Okay, so that will be 210. So put 210 there. 7 into 210, I'll get 30. So it will be 6 multiplied by 30 plus 6 into 210, I get 35 multiplied by the 1 on top minus 15 into 210, I get 14 multiplied by the 14 on top. So what I have now here is 6 multiplied by 30, which is 80, plus 35 minus 196 divided by 210. Okay, so if you punch this into your calculators, okay, you should be able to get 19 over 210. And that will be the answer. Okay, so that's our final answer there. So when we used type 1, okay, we found that our integral, when we evaluate it over this region as type 1, we get that our integral will just be equals to 19 over 210. So now, we want to integrate this same integral, okay, but over the type 2 region, this one here. So I'm going to say my integral is equals to, okay, the integral, so the continuous functions down are along the x, and then along the y, we have the constant. So this will be x is equals to 0 to 1, and then this one will be y is equals to 0 to 1, okay, and then x will be from y to the power 3 to y squared, and then I have 2x plus y squared, okay, and then this one become dx dy, okay, because the x is the one now that is inside. Okay, so when we multiply, when we evaluate the inside integral, what do we get? So this is 0 to 1. Here we're going to get 2x squared over 2 plus x y squared, and then I have y to the power 2, y to the power 3. Okay, so let me write that one properly. So this is like that. Okay, and then I have dy. So now let's substitute those limits. So if I get this one and put there, you can see that actually this 2 and 2, they cancel out. So I just have x squared. So I'll put y squared plus, wherever there's x, I put y squared multiplied by y squared. And then I can substitute this one. So it will be minus, where there's x squared, where there's x, I put y to the power 3 and then squared minus y to the power 3 multiplied by y to the power 2 and then dy. Okay, so what do we get here? The integral from 0 to 1, this will be y to the power 4 plus y to the power 4 as well. This one will be minus y to the power 6 minus, these ones have the same base, so you just add their power. So that is y to the power 5 and then dy. Okay, so basically what we have is this. Okay, basically what we have is the integral from 0 to 1 of 2y to the power 4 minus y to the power 6 minus y to the power 5 and then dy. So we can integrate this easily, right? So it will be 2y to the power 5 over 5, okay, minus y to the power 7 over 7 minus y to the power 6 over 6. And then we're evaluating this at 1 and 0. So if I put 0, everything will be 0. So the only one that we consider is the 1. So it will be 2 over 5. If I put 1 here, minus 1 over 7 minus 1 over 6. Okay, so let's try to evaluate that now. Okay, remember the answer that we got from type 1 was 19 over 210. Okay, so now let's try to evaluate this. So this one, the common denominator there will also be 210. So 5, okay, into 210, I get 42. 42 multiplied by the 2 on top, minus 1, which is on top. 7 into 210, I get 30. Okay, and then minus 1. 6 into 210, I get 35. Okay, so now this will give me 84 minus 30 minus 35 divided by 210. So it means my integral will be equals to, okay, so when I do 84 minus 30 minus 35, I'm getting 19 over 210. Yeah, okay, so this is correct. We get the same answer. So whether you choose the type 1 region or the type 2 region, we're still getting 19 over what? We're still getting 19 over 210. Right, so that's all for this video.